Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and I'm actually re-recording this because I found a glaring error in one of my graphics and posted an update about that. But instead of you having to look at the video and then look at the next post and try to plug that into the video, I just thought let's just get it all right in one shot. So that's what we're doing here. And again, it is, as I warned the first time, it is math intensive. So if you don't like math, it's probably Miller time, and we'll have a less intensive math video for you on Friday. All right, so let's go ahead and put myself down in the corner here. And we have talked a lot over the days, months, and years now about thickness. And the thickness is the distance between two surfaces of constant pressure. Now, these surfaces of constant pressure, you can sort of look at it as a topographic map, you know, where the elevations go up and down. Same thing with this, that when a low pressure area is moving in, the distance you have to go up to reach a certain pressure is going to be lower. And then if you have a high pressure system moving in, that height is going to be higher. So it's sort of an undulating surface that goes up and down all around the globe. Okay, so what we're going to do now is take a look at a little math review here. So here's the equation, and it says if you have two surfaces of constant pressure, P1 and P2, and you take the natural log of that ratio, that is equal to the gravitational constant, which is 9.8 meters per second squared. That's the rate at which objects accelerate as they fall toward the Earth due to gravity. A gas constant times the temperature, the average temperature of the layer between those two pressure surfaces, and then the thickness, which is the actual distance between the two pressure surfaces. Okay, so that's the basic equation we're working with. So what are the values of these different variables? Well, R is equal to 287 joules per kilogram degrees Kelvin. Now, don't worry about the units. The only reason I put those there is that when I was in college, if you didn't show the units, you didn't get credit for nothing, okay? So in case a scientist is watching this and says, Greg, you know better than that. You need to have units up there. So that's why they're there, but don't stress out about it if it doesn't mean anything to you. The gravitational constant is 9.8 meters per second squared. And then I'm going to take two arbitrary pressures. One is 1,000 millibars, which if you're at sea level is near the ground, and 925 millibars, which if you're at sea level or near there would be about 2,500 feet up. And I'm going to use two temperatures 1 degree Kelvin apart, which is also 1 degree Celsius apart. We use Kelvin because that's the variable or the unit that this equation mandates. So T1 is going to be 273.15 Kelvin, which is 0 degrees Celsius or 32 degrees Fahrenheit. It is the freezing point. And then T2, we're going to up it 1 to 274.15 Kelvin and see what difference that makes in the thickness. So let's plug in the numbers now. Natural log of 1,000 over 925 is equal to 9.8 over the product of 287 times 273.15 times the thickness. This is what you get when you do that math, and if you divide the left by the 0.000125009, you get a thickness of 623.645 meters for the average temperature being at the freezing mark. Okay. Now, let's up the temperature of 1 degree C. So now the denominator on the right side is 287 times 274.15. And in that case, you get these numbers, and when you do the math, you get a thickness of 625.928 meters. So, thickness 1 is 623.645. Thickness 2 is 625.928. The difference is 2.283 meters, and so that equals 1 degree Kelvin or 1 degree Celsius. But a 1 degree Celsius is 1.8 times as big as a degree Fahrenheit. So we have to take 5/9 times 2.283 to get how many meters correspond to a degree Fahrenheit. And when we do that, we get 1.268 meters. So for every, in that layer, for every 1.268 meters increase in thickness or decrease, the temperature will go up 1 degree Fahrenheit or down 1 degree Fahrenheit. So the forecast, and since I'm now recording this on Thursday, this would have been Tuesday's forecast, I guess. The ensemble mean temperature forecast for yesterday was, which would have been Tuesday, okay, was 50.9, and the ensemble mean forecast for the max temperature on Wednesday was 54.8. That represents an increase of 3.9 degrees Fahrenheit. Tuesday's high was 53, so the implication for Wednesday would have been 56.9. Now, if we take a look at the 24-hour forecast thickness change from 7 a.m. Tuesday to 7 a.m. Wednesday, it was 10.9 meters. And the 24-hour change from 7 p.m. Tuesday to 7 p.m. Wednesday was 4.0. So I average those two, get 7.45 meters, divide it by 1.268, which is how many meters correspond to each degree Fahrenheit, and we get 5.9 degrees Fahrenheit, okay? That implies a max temperature today of 58.9, because remember the high Tuesday was 53, you add 5.9 to that, and you get 58.9. Well, the max temperature yesterday at Centennial was 58, and it was 60 at RDU, and 58.9 is right in the middle. The ensemble mean forecast was 56.9, so it was just a little bit too cool. So we're not talking about a huge difference here, but there have been times where I have seen the thickness approach work 2 to 3 degrees better than just taking the raw numbers from the model or the ensemble mean. So this is something I use, but I have to be careful because it only works on days where there's a fair amount of sunshine. If you've got a big storm coming through and there's a lot of clouds and precipitation, then this ain't going to work, okay? So when I took a look at the forecast yesterday, I used the thickness technique for Thursday, Friday, and Saturday, and then for Sunday and Monday, when I think there's going to be a fair amount of clouds and rain, I went more with the ensemble mean in that situation, and then when we get the sun back, Tuesday and Wednesday, went more with the thickness technique, okay? So just wanted to give you a little bit of a behind-the-scenes look at the method to my madness and how I come up with the various numbers that I do. Okay, that is it for now. That is bonus weather video number 2 for this week. Hope you have a wonderful rest of your Thursday, and the next bonus weather video will be Friday, and just a little bit from now, the next daily weather update will be coming up later this afternoon. Y'all take care, folks, and we'll talk to you soon. See you later.